So it's roughly the average distance each data point is from the mean. And the nice thing about standard deviation is this part. It uses every single data point versus when we did the range, we only did 2 data points. We did the smallest and the largest. When we did the interquartile range, we only used 2 data points, Q3 and Q1. So it didn't really get a big picture. It only had specific values, whereas standard deviation uses every single value. Since it is a measure of variability or a measure of spread, it's kind of nice, again, because it takes into account each value instead of just a few. So in other words, it's another option we have for looking at variability. Now, looking at every single data point can be good, but it also could be bad because sometimes we have those extreme values. And when we have the extreme values, things get thrown off a little bit. So kind of like mean and median, we'll have to make a decision. Should I be looking at range or should I be looking at standard deviation? So eventually we'll have to decide between those two things. So before we look at how we find the standard deviation, I want to add it to our list that we had back in section 1.3. So we're going to go back to our 1.3 notes again. I know I keep having you backtrack. We'll find the one that talks about describing the distributions. So we've described the distribution with our shape, with our center, when we talked about either mean or median. And so now we have variability. So with variability, we're either going to look at the range with the IQR, or we're going to look at now the standard deviation. Like I said, sometimes one of them will be a better description than the other. The only thing we have left is the outlier, which is what we'll talk about in the next section. All right, so standard deviation is an option. We need to know how to find it. When you first look at the formula for standard deviation, it's kind of intimidating, but we'll break it down and it'll make it a little bit easier to deal with. But hopefully I gave you those values. And what we're going to try to do is figure out, well, what's the standard deviation for that set of values? Let me show you the formula first, just in case you happen to run across it at some point in time. Again, when you first look at it, it looks like a big mess, but here's the formula. We use S with a little subscript of X to represent standard deviation. So if you ever see that, S with a little X, that's what we're talking about. The pieces, though, of the formula, the y is just the data value. Remember, standard deviation eventually uses all the data value. The y bar, what did we say the other day x bar was? Did our calculated what was x bar? I'm sorry. The mean. The y bar is still the mean. N is just the number of values. Now, if I'm looking at my data, it's just coming data. So those are the pieces. So even though the formula looks really messy, the data value will be given to me. We know how to find the mean, and it's easy to count how many values I have. And then it's just a matter of putting that into the formula. But again, I think it's easier if we kind of break it down. So the way I usually like to attack it is I create this table. And so first of all, in your table that I put on your notes packet, go ahead and enter in the numbers. So those are just the data values that we had. And I don't remember, I may have shorted you one. I gave you one too many.
The values in order from smallest to greatest.
You can, but you don't have to. But I give you an extra row of this. All right, well, one of the things we need to use in our formula is the mean of the observations. In other words, I need to find the mean. This one may be just as easy to do by hands. Let's see, I got 14, 17, 24, 25. So I'm going to take 25 and divide it by 6 values. So 25 divided by 6 is 4.16 repeating. So I'm going to round it to 4.2. Now that doesn't change, so that's 4.2 all the way down. All right, so again, that's something we've done before. The second thing says the deviations. Well, the deviations are how far away we are from the mean. So to find that, I'm just going to take the original data value minus what I just found out the mean was. So I'm going to do in this one 5 minus 4.2, and that first deviation is 0.8. And I'm going to do that for each one. Now you'll notice sometimes you may end up with a negative. That's okay. Like on this third one, 0 minus 4.2 can be negative 4.2. So some of those answers will be negative, and that's okay. But go ahead and see if you can find the different deviations. So think about the deviations. Any positive deviation means the value was above the mean. Any negative deviation means the value was below the mean. Okay, the next part says take those deviations and square them. Now, anytime I square a number, what kind of answer should I get? Positive or negative? Positive, right. So even though I had some negative values in this column, I should never have any negative values in this column. All right, I'm going to go through and just square each one of those. This time you may want to go to 2 decimal places. Something on the graphing calculators that you'll have to be careful of when you square things. If I put in negative 4.2 squared like that, it's going to give me an answer that's negative because they're doing 4.2 squared and then doing the opposite. So if you're going to enter it in, technically you'd have to put parentheses around the 4.2, negative 4.2. What I usually do is, since I know it's got to be positive anyway, I just forget about the sign being there. That way you don't worry about it. So double check your values just before we move on, make sure we don't have a wrong value in there. I'll make sure I didn't do something wrong. Did I do something wrong?
I kind of missed the second one.
This one here. I did it by hand, but I did the mean by adding up all these values. And so I got 25 and then divided by 6 because there are 6 numbers. All right, so kind of tedious work, but nothing really too difficult necessarily. Finding the mean was probably the hardest part. Then it's just subtraction and squaring. If I go back to my formula, here's what we've basically done so far. We've done y minus y bar, and we've squared it. So we're taking care of that part. Well, next to that is this symbol right here. Anybody know what that symbol means? What they're asking us to do with those values? That symbol, it's actually the Greek letter sigma, but it's representing the sum. So what we're going to do is we're going to take all those numbers in this last column and we're going to add them up. So we're going to find the sum of all the squares of those deviations. All right, so now we've done everything there on the top. We've done the sum of all the deviations squared. Well, the next thing it says divide by n minus 1. Or remember, n is how many values we have. Well, in this list here, we already decided we had 6 values. So I'm going to divide that by whatever 6 minus 1 is, or I'm going to divide it by 5. It's 60.84, I'm going to divide that by 5. And we'll just do 2 decimal places, so 12.17. That 12.17 is referred to as the variance. I know there's a lot of terms here, but the 12.17, what we just got there, is considered the variance. Finally, we're ready for our final answer, and that's the standard deviation. Well, the standard deviation is the square root of our variance. So in this case, it's the square root of 12.17. And so to 2 decimal places, that's 3.49. That would be our standard deviation. Well, big deal. What's that telling me? We did a lot of work, we got a number, but what's really the number mean? Well, the standard deviation, remember, is the average distance that our data points are from the mean. So we would say in this case, since the standard deviation is 3.1 or 3.49, I'd say the average distance from each point is 3.49 from the mean. Now, maybe 3.49 above, maybe 3.49 below, but on average, it's around 3.5, 49 away from the mean. The larger the standard deviation, the further away from the mean we are, which would mean my data is more spread out. If I have a small standard deviation, that means it's not very far from the mean, which means my data is fairly close together. Just like when we did range, we said if you had a big range, it means it's spread out. Small range means it's close together. Now, if I ask you to find the standard deviation by hand, I'll give you this setup for the problem, like if you got on a quiz or something like that. So you don't have to necessarily memorize the formula, but you just have to remember how to fill in the values here. Ultimately, I'll show you maybe a little bit faster way of doing it. I'll show you a couple ways in this calculator. But I think it's important to see where it comes from. All right, so kind of putting all this together, some things to think about with standard deviation. When you get an answer for standard deviation, it's a distance or an average, so it always has to be either greater than or equal to 0. And you can never have a negative standard deviation. You could just add this below the, I think I have a couple fill in the blanks for the next thing. Add this down below. So that's a good way to check yourself. Make sure you're on the right track. If you end up with a negative answer, you're off somewhere. Like I just mentioned, if I have bigger values of the standard deviation, the bigger the value, the greater the variation, or the greater the spread. Standard deviation is not resistant. Remember the other day we talked about resistant means it doesn't change much if you had a really big or really small value. Standard deviation does change if you have a really big or really small value. It can be moved quite a bit. That kind of makes sense because when we did standard deviation, what was the first thing we found in that table? What was the very first column? The mean. And the mean was not resistant. So if the mean's not resistant, and that's what we use, then that means standard deviation is not going to be resistant. Okay, that's because, again, this is based on the mean. So if it's skewed left or skewed right, we don't want to use standard deviation. If it's symmetric, then it's okay to use standard deviation. So those last two kind of tie together. Okay, so outside of finding standard deviation, this next thing is really the important part. How do I choose the measure of center and the variability? Well, first question I ask myself is it skewed or not? If I find out that it is skewed, a skewed distribution or one that has an outlier, and we'll talk about outliers in the next section. If that happens, we're going to use the median, and we're going to use the range with the RQR. That's if we have skewed data. So we'll still find those other things, but if I'm really describing it, I would describe it using the median and the range with the IQR. If I find out that it's roughly symmetric, and again, it's hard to get exactly symmetric, but if we get fairly close to symmetric, and we find out there are no outliers, that's when we use the mean, and we'll use the standard deviation. So if you remember at the beginning of the semester, we talked about collecting data, doing the computations. That's important, but the analysis is really important as well. So the analysis would come in here. So we do all those computations, and then we look at it and say, okay, well, should I be talking about my data using mean and standard deviation, or should I be talking about median and range? And I think next week, maybe the week after, we're going to start a project for Chapter 1 where you're going to have some data and you got to start making some of those decisions. So we'll have to actually put that into practice. All right, so that's section 1.7. Chapter 1's kind of a long chapter, obviously, but 1.8 is going to deal with outliers. So we'll talk about how to deal with outliers. And then we're actually going to start the chapter project before we do section 1.9. We'll do the project, we'll come back to 1.9, and then eventually we'll have our test for chapter 1. So we're a few weeks out from our finishing up chapter 1. We're getting closer. I'm going to go ahead and give you the problems for 1.7. So you have some time now. Kind of like I did on Monday, I'm going to give you time on Friday as well. So I'm going to give you probably 30 minutes or so at the beginning of class on Friday. But I'd like to have those completed by the end of class on Friday. So they don't have to be done when you come in Friday, if you're gonna have time. But maybe if you want to get started on them, get an idea of what you're looking at. And then my plan on Friday is to do an activity that you're gonna need your device for, so try to have your laptop with you on Friday. Okay, but again, this will be due at the end of class.